Well, good morning, ladies and gentlemen, and welcome to this webinar to introduce you to the PROBITY project and the exciting world of precision breeding. My name is Tom Allen Stevens. I lead the British On-Farm Innovation Network, and we also lead the project that's set to bring precision-bred crops to commercial farms for the first time across Europe. But before we get stuck into precision breeding, I just want to highlight a couple of things that are coming up over the next few months. So I'm just going to quickly share my screen. I hope this is going to work. Can we all see that okay?
Yeah.
Great. So the first one is the Adopt Fund that's offering farmers for offering funding for farmer-led on-farm trials. DEFRA has released more information on the two-stage process of getting funding. So you get £2.5 to work with a project facilitator to put together a bid for a project. BOFIN is a registered project facilitator, and we're keen to work with farmers to develop ideas into full projects. Now, these are competitive bids for 50 to 100 grand 2-year projects. So it all kicks off on the 28th of April, and there's an Innovate webinar on the 30th of April. Now, these tend to be a bit dry. So BOFIN has brought together a panel of experts in farmer-led research for a webinar the next day, that's on the 1st of May, to discuss the sort of projects likely to be successful and how to go about applying. Now, if you're interested in applying, please register your interest with us and we can discuss your idea. Or come to see us at the Farmers Weekly Transition Live event on the 8th of May at University of Leeds Farm. We're running a seminar in the programme specifically focused on Adopt, and there's an innovation hub where you can talk to us and others involved in this new fund. Now, note that the window for the first round is open for just 6 weeks, but there will be a second round opening shortly after. Now, we have other events lined up over the summer, over the spring and summer. So if you're one of our 73 BOFIN trialist farmers, first of all, thank you. You're doing a brilliant job. And also, please come to our Inspiration Days in either Kelso or Cambridge. It's a chance to discuss and shape the trials. You'll be the first to see the new BOFIN trialist app. We'll have a beta version for you to download and try out. And it's a chance to find out about our Innovation in Action farm walks. So we'll be supporting those farmers who would like to host a farm walker event to show other farmers the trials they're carrying out. Now, we're also exhibiting at both Cereals and Groundswell. Look out for the Haven of Inspiration. It's bright maroon. You can't miss it. We'd love to see you there. And we're planning to have a get-together at both events as well. So look out for details. But anyway, on to precision breeding. So here's the running order for the webinar. I'm going to give a brief introduction to the project and then hand over to Professor Cristóbal Uauy from John Innes Centre, who will look in more detail at precision breeding techniques and the potential benefits. We'll then bring in Nigel, Halford, and Dylan Phillips, Nigel from Rothamsted and Dylan from Aberystwyth University, who will look a bit more at what changes in the legislation have happened and what the implications are of those. We've then got Paul Temple, who's going to be joining us and talking through his experiences. Paul was involved years ago back in the field scale evaluations of GM crops and has been very actively involved in novel breeding techniques and implications for farmers ever since, being a member of the Global Farmer Network. So we'll have a chat with Paul, and then we'll open up for a Q&A. And you'll see at the bottom of your screen a Q&A thing and a chat button. So do put comments into the chat. And if you've got a question that you'd like to direct at anyone in particular or direct at the panel in general, then please put that into the Q&A, and then we'll come to that towards the end. By all means, put in questions as we go along, and we'll certainly look to address those as we go along. Certainly in the legislation bit, for example, there's an awful lot to unpack in the legislation. So if you've got any specific questions, then do let us know. Now, so what is PROBITY all about? Well, it's a platform to rate organisms bred for improved traits and yield, and it's specifically to address this productivity challenge we have. So the red line there shows us where we're going with our wheat yields. Wheat has basically plateaued in terms of yield. Where we need to be is the green line. And that means we need to step up productivity over the next 25 years by about as much as we have over the previous 50. And that is quite a challenge. Now, everyone talks about plant breeding being the answer. Well, yes and no, in that, as we know, it takes an awful long time to get a new trait and a significant improvement in plant breeding to market. It's about 10 years currently to get to a stable line. And then you've got another 5 years at least on top of that before you've actually got it commercially available. You can cut that down with precision breeding quite significantly, especially those earlier years until you get to the stable line. But there's still that pause. And with precision breeding, of course, there are barriers that come in to do with the uncertainty in the supply chain, regulatory barriers. And that feeds back to the plant breeder. And the plant breeder needs to have confidence in the farmer that the farmer will grow it, and the farmer needs to have confidence in the consumer that the consumer will eat it. And currently, that is questionable. So what we're looking to do with PROBITY is to strip that unconfidence away in terms of getting right there. As soon as those traits are developed in the very early stages, multiply it up and put it to the food manufacturers, create the food, and that will show whether the traits are real, whether they actually work in real practice, and allow confidence to filter back through the supply chain. That's what we're aiming to do. How are we going to do it? Well, we're multiplying up over the course of the project. We take a kilogram of this new PBO seed, as it's known, precision-bred organism, and multiply it up to 100 tons for processing in less than 3 years. That's the aim. We're then going to be putting that through field trials, which are monitored by farmers working closely with experts. The produce will be processed into iconic British brands, or it'll be fed to livestock. We've got 3 cereals that we're bringing through in the course of this project, and that's what we're going to be looking at. One of them specifically looking at the food qualities, one of them specifically looking at the advantages for livestock. Now, in parallel, we're also going to be editing 3 leading wheat varieties and 1 ryegrass with the new traits as well. So hopefully those will be done by the end of the project. There won't be enough to actually grow on farm, but hopefully the edits will have been successfully made by the end of the project. And we see it as a start of a pipeline of new traits. There are some really exciting traits in our own research institutions across the UK and worldwide that we could look at developing on this platform. And remember that this is the only place in Europe where we can grow them on commercial farms. England, indeed, it's the only place in Europe. So it's a real opportunity for UK farmers to get involved in what is a very exciting technology and look to explore its opportunities, be one of the first in the world to do so. So how can farmers be involved? Well, as I say, there is going to be material available for farmers to grow. And the first of that material will be available this autumn. So we are actively looking for about 25 farmers overall to grow these varieties. And keep a lookout for the emails that we'll be sending out about this. And as I say, do get involved to find out more. But also we're looking for PROBITY pathfinders, and these are thought leaders in farming, people with a real credible network to talk about precision breeding, to come on to do press interviews, to come on to seminars and things like that and events. And so you don't have to be supportive of the technology. We're looking for all views to come together. The reason for that is that we really need the farmer discussion. So everyone can get involved and bring their views to the sequence circle, which is the main area where we're looking to gather views. This is a new forum on the Farming Forum, and it's really, really important that farmers put forward their view. Government is listening. The world is listening to how UK farmers, or more specifically, English farmers, feel about this technology and the experiences that they have when they grow it but also any concerns that they have, any knowledge gaps that you have, any opportunities that you feel need to be developed further. Government, as I say, is listening. The rest of the world is listening. We're doing some analysis of the views that come on to really understand what farmers' views are about this, and the rest of the industry as well. So that's, and as I say, that's all happening on the Sequence Circle, a new area on the Farming Forum. Please go there. The main thing is that we've brought together a lot of information as well about precision breeding and about the technology. So please do spend an hour at least finding out about this information, and then bring your views. Get the discussion going on the Sequence Circle. It's a really, really important discussion, and you can play a very important part in it. So that's as much as I'm going to say. So I'm going to hand over now to Cristóbal Uauy. So Cristóbal, if you'd like to join us, great. Thank you very much, then, Cristóbal. I'll leave you to take it away.
Thank you very much, Tom. Good morning, everyone. So today I'd like to give you just a little bit of a background on the technology and some potential benefits. And one way that I like to put the context of this is that a lot of the work we do is trying to understand how plants perform in the field to address that yield gap, for example, that Tom commented on. But at the same time, we're trying to understand what is the genetics, what is the sequence behind those improvements that we can make on farm. And importantly for us is that often these traits that we're trying to improve have to do with changes in DNA or mutations. And we normally think about mutations in a slightly negative connotation, but actually, if I would say the word diversity, everyone would be more positive. So all the diversity you see in this picture, for example, of peas, has to do with small changes in DNA or mutations that lead to this incredible diversity that we enjoy on our farms. And importantly, not only is that diversity out there, but humans have been extremely successful as a species in selecting this diversity. And I show this one example of Brassica oleracea, which would be a common weed originally, maybe 8,000 years ago. But over time, people started selecting for larger buds and started selecting Brussels sprouts, or a slightly different head and started selecting broccoli or cauliflower, or larger leaves and selected kale. So actually it's the same species, but just small changes in DNA start making a kale or a broccoli or a Brussels sprout. And these small changes, we have selected them for the benefit of agriculture. And we've done the same with our dog breeds and cats, etc. So when we think about DNA, this is basically how DNA looks like. It's just a whole string of letters of A, C, T's, and G's. And it looks quite boring in a way, and it's quite large. So just to give you a context of this, if I were to take the wheat genome, for example, and print it out on A4 sheets of paper on both sides, I would actually have 3.1 million pages of DNA for one particular variety. And if I were to stack this up, it would actually be taller than all the landmarks in London. It would be 323 meters. So you can imagine the work we have to do in trying to identify how particular sequences, these pages of DNA, how they confer those traits to improve performance in your fields. But now that we can actually take advantage of this genome revolution, where we can sequence genomes, we can get all the information in these pages, what we found is that a lot of the changes that we see in the field can come down to small changes. So within these pages, there are particular regions or genes that confer these traits. And what we find is that when a plant is perhaps slightly more resistant to a disease or a pest or pathogen, it might have a small change, just maybe those 5 letters there that suddenly are missing, and now that instruction is slightly different. Or perhaps one letter, like this T, can change to an A. And when that happens, now the plant is more resistant to a particular drought event or has slightly longer roots. So it's a combination of these small changes or mutations that we have selected within our breeding programs. And these changes can also be close to the gene. Importantly, all the variation that we see in the recommended list is basically derived from these small changes in DNA. So when we think about mutants, every plant that you have growing in the field, all the varieties are mutants, are just different forms of that original wheat plant that was originally found maybe 10,000 years ago. And thanks to that selection by breeders, by farmers over time, we have that diversity of wheat cultivars for bread making, biscuit making, animal feed, etc. So we've taken advantage of this natural variation, this variation that happens naturally through traditional breeding, where we find plants that are slightly different, and we make a genetic cross to find a plant that will combine the beneficial traits of both of those original plants. And when we think about how many mutations we have, if we go back to those 3.1 million pages of DNA that every wheat plant has, within that, there'll be roughly 100 mutations that happen in every generation. So every seed in the field, in your fields, basically has about 100 mutations. So if you actually multiply it, almost the whole genome will be mutated in a few hectares in your fields. But actually, it's quite hard to find the individual seed that has that mutation. But when we can see it, we can select it as we've shown before. And we basically use this repertoire of 100 mutations. But over the last 100 years, we said we want to go slightly faster. And we've introduced mutation breeding. And in this case, instead of taking advantage of just 100 mutations per generation, we actually have 500,000 mutations in one single generation. So it's basically a numbers game, as breeding is. So we basically put the odds in our favor by having more mutations in these plants. And again, if we find a plant that has a beneficial trait, we can then select it and use it in traditional breeding. But again, it has a lot of baggage because of these additional mutations. In the case of transgenics that we also mentioned, or GMOs, it's slightly different here, because what we do is we literally take a page from the genome of another species and we then insert it within those 3.1 million pages. And it's effectively that. It's roughly the equivalent of taking one page and putting it within the 3.1 million pages of the wheat genome, and then seeing if that page will confer a beneficial trait. And this is our nice examples are coming to market, which are for public good. For example, the purple tomato by Kathy Martin. So what is genome editing then? So genome editing is a case where we can do specific changes in DNA and in a very targeted manner. And often these changes are to do small little changes in DNA where we remove or alter DNA. So the way that this actually looks in real life is something like this. It's called CRISPR, which is a more typical method, and it looks quite complicated. But in reality, what it is two components. It's a Google search box that we will introduce a particular sequence so that the molecular scissors will cut the DNA at that position. So now that we have the genome available for most of our varieties, we can actually say, I want to take this molecular scissor to a particular place in the genome, and I wanted to make a cut. And when that cut is made, we generate a mutation in that particular place. So what happens is that that plant will basically look something like this. We'll have maybe 5 basis changes, or 5 little dots that are changes, or maybe one letter, that C, will change to a T. And these are the mutations that are generated by genome editing. So if you look at this slide and the slide I showed you before of those mutations that happen naturally, but just very slowly, you'll see that they are actually the same, because mutations that are generated by genome editing are indistinguishable from those that occur naturally. And hence why there's so much excitement, because we can actually, instead of taking 100 mutations, we can actually get 101 mutations, this extra one mutation that can have the beneficial trait. And it basically looks exactly identical to any mutation that would happen in nature. And those mutations are probably out there in your fields already, but how hard would it be to find the individual plant that has the mutation we want? In this case, we actually can generate that and then go back to the field and test it on scale, as we're trying to do here in BOFIN. Just to give you a little bit of idea in terms of expectations or what we can expect, I think first of all, we want to manage expectations, that it's part of a toolbox that breeders will use. We will not generate a new variety out of scratch. The whole idea, the whole kind of opportunity here is that we can take varieties that are already on the market or near market, and we can actually improve them and make them even better to then go to the field. So it's not going to be making a complete new car, but it's just changing, tweaking certain elements as we go. So we can start, for example, when we have a particular gene that's very interesting in a wild species, or that in something that will be very hard to do by crossing that might take 10 or 15 years, we can actually start recreating some of those within our elite cultivars. We can take diversity that's been left behind through the last 100 years of breeding and bring the diversity back into modern lines. Importantly for us, we have this quicker translation from the laboratory to the farm and then to fork. And for us, that's very important. And that's because we can actually edit elite UK varieties now for the first time. It will give us an opportunity to think about other markets or more niche markets. Often we can improve health and nutritional traits, among others. But what happens is that since the chain is so long, since it takes 15 years or 12 years to get to market, there's very little appetite to innovate or to be entrepreneurial. In this case, the risk of doing this is much lower because within 3 years, we can start having the first lines to test of a UK adapted line in farms to test. And we can already start modifying some simple traits between quotes, and these are some of the traits that we're looking at now. And just to give you an example of some of the traits we're looking at, this is, for example, a particular gene for mildew resistance. We can also do for yellow rust, which are trials that we're now doing with Diane Saunders, and we're doing some initial trials actually in Kenya and in Egypt on these lines. We can change the starch morphology. So this is the wild type starch of wheat that has these two type of granules. And we can actually now generate, through David Sung, he's generated a whole set of varieties with different types of starch granules with all different sorts of end uses. And now we're testing those to see how they could be used for industry and other applications. Colleagues in Japan have mutated one particular gene that confers extreme resistance to pre-harvest sprouting without affecting germination in the farm in the next year. And we're also doing work here to get deeper and steeper roots as part of our efforts. So just some final thoughts for discussion. There's still lots of considerations, and that's why it's so important that we have this dialogue. This is not simple to do. There are still intellectual property issues that we need to discuss. We need to find the ways of how we integrate precision-bred organisms within the national list and recommended list. We need to think about international and even national trade. Of course, as Tom said, this is England, not a UK legislation at the moment. But at the same time, we are in the middle of this genetics and genomics revolution that really allows us to take advantage of these approaches going forward for the benefit of farmers and consumers. Again, PBOs are part of a broader toolkit. The challenges are so vast, I think, that we need everything we can to address them. Thankfully, we have now a more proportionate science-based regulation that allows us to promote innovation. And PBOs, I think, offer the first time this incredible opportunity for the academic world to work much more closely with farmers, as we're doing today, because of that shortening of the time frame, and because we can actually take varieties from breeders and improve them directly ourselves, rather than needing the whole 15 years of chain of the breeding. So with that, I think I'll finish there, Tom, and we can then move forward.
Great. No, thank you very much for that, Cristóbal. If you'd like to stop sharing your screen, I just wanted to say congratulations to you, Cristóbal, who you've recently been promoted to director of the John Innes Centre, and I think your position, you're taking up the position in the autumn. Is that right?
That's right. Thank you, Tom. Yeah, in September I started the position.
No, that's great and well deserved. Really looking forward to working with you on this project. And Cristóbal's bringing on a couple of lines that we're bringing through within the project. Also working with us is Dylan Phillips and also Nigel Halford from Rothamsted. If you'd like to switch your camera on, Nigel, and if you'd like to stay with us, Cristóbal, and now Nigel is your technical lead on the project. So would you just like to introduce yourself first, Nigel?
Sure. I'm Professor Nigel Halford. I'm a project leader at Rothamsted Research. I've been there many years. I've been working on GM and more recently GE crops for a very long time.
Fantastic. And Dylan, would you like to introduce yourself?
Yeah, my name's Dylan Phillips. I'm a lecturer in Aberystwyth University, but very interested in crop biotechnology, particularly transferring the technology into more niche products. So Aberystwyth has a big interest in forage grasses, and applying this technology to other species is challenging. But I'm also interested in legislation and the regulation surrounding the use of this technology too.
Great, and that's where I wanted to start with, if you like. Nigel, would you like to just say, what is the change that's happened in the regulation, and why is it specific to England?
Well, there have been a number of changes that happened. 2 years ago, the government introduced a change to what was in the GM regulations to allow us to do field trials of genome edited crops much more simply than we've done before. So with a simple notification to DEFRA. And that was followed last year by the PBO Act, you might want to call it that. That introduced the term precision breeding organism. That's a genome edited plant, as Cristóbal has described us very well, with no GM element to it. So it has to be non-GM to qualify as a PBO. And there's going to be 2 categories of PBO, one for research only, and a second category for marketing. And of course, we don't know yet exactly how it's going to work. We had secondary legislation was passed in March. All seems to be going ahead. I think it's going through the Lords at the moment, right? Seems to be going through unscathed. And then we'll be in a position to actually see genome edited varieties on the market for some crops, which is, just fantastic. Of course, we have to see how it's all going to work. So there'll be an approval process from ACRE, that's a scientific committee within DEFRA, just to confirm, yes, they agree this is a PBO, i.e. genome edited, non-GM organism. And then the FSA will have a process of risk assessment as well, though they assure us it's going to be relatively straightforward.
Sorry,
that's how that works, but really...
Sorry, Nigel, that's the Food Standards Agency you're talking about there?
Sorry, carry on.
Sorry, I was just going to say that's the Food Standards Agency, FSA.
Yeah, Food Standards Agency, yeah.
So why are they involved in the process then?
Well, why are you asking me that, Tom? Well, I think, you could argue, well, these things, as Chris Mallett said, the mutations introduced by genome editing are the same as those occur naturally. They're just targeted. So you could argue that you don't need any additional oversight compared to, a variety produced in the conventional manner. But I think to ensure that everybody is reassured that everything is being brought in a controlled way, and that there's expert people checking on the safety of these things, then that's why we have this process. It's important to say that process, it's not, I think it's going to be straightforward. I hope so. But it is more straightforward already in some other countries. So we do have to bear in mind, we're not ahead, and most countries we're behind, and our process will be take a bit longer than that in some other countries.
Good. Can I ask you, Dylan? I mean, so Nigel's talked about the process there. I mean, you've been involved in this area for some years, and you've seen the legislation and regulation evolve, if you like. I mean, what can we expect to see over the next 6 months then, in terms of, because as I understand it, once the legislation is laid, I think is the term, then there's then a sort of cooling off period, if you like, for 6 months before it's actually implemented. So what happens over that next 6 months? Then what can we expect to see? If I'm a scientist with a new PBO or whatever, what do I actually do?
Yeah, so as Nigel mentioned, in February, the genetic technology regulations, the second bit of the legislation was laid to Parliament, and this really details the process that a researcher or a plant breeding company would need to go through to apply to DEFRA. So that would be the first step. And what DEFRA will be looking for is to establish that it's not a GMO, so it's not carrying any additional sections of DNA that wouldn't be naturally found in the plant. And there's a big focus on equivalence in the legislation as well. So what they're looking for are changes that could have been created via traditional methods. Now, this isn't easily defined because plant breeding is very diverse. There's lots of things you can do. So part of DEFRA's role would be to look at the changes made and establish whether they could be generated using traditional methods. And this should be a fairly easy thing for a researcher to establish. So that's the first stage, is kind of, is it equivalent to what traditional plant breeding can achieve? Once it reaches that goal, it will be passed on to the Food Standards Agency, and they will be looking at a range of criteria. And we're expecting the first applications to go into DEFRA in the autumn. They have 90 days to review that application, and then if it's rubber stamped, then it will be passed on to the Food Standards Agency panel. So the panel have existed for a long time. They look at novel foods traditionally, and that are going to be brought into the UK, and their role is going to be looking to see what kind of changes have been made, and how that could impact nutritional content, toxicity, allergenicity, and the secondary legislation provides much more detail now on the type of evidence that they'll be expecting to get.
Great. No, thanks, Dylan. Now, you mentioned about the food legislation there and relatively novel foods, I suppose. Now, one of the lines that we're bringing on within this is looking at acrylamide levels in wheat, and this is work that you've been doing for some time, Nigel. Could you just tell us a little bit about the low acrylamide wheat that you've been developing?
Okay, if people are not familiar with the acrylamide problem, acrylamide is not present in wheat grains or any other crops, but it forms during normal cooking and processing, including baking, frying, toasting. It's a highly undesirable chemical to have in your food. It's probably carcinogenic. It's neurotoxic, affects fertility. Of course, it's present in parts per billion levels, but some foods have several hundred parts per billion. Now, we already have regulations on the presence of acrylamide in food that rolled over from the EU at Brexit. So we have benchmark levels, for example, which food businesses have to work towards benchmark levels. Now, the EU is expected this year, I mean, we've been expecting it for a while actually, to set maximum levels, i.e. levels above which it would be illegal to sell a food product. So that's a juggernaut coming down the road for the European food industry, and it will affect the UK supply chain as well. So acrylamide, it's quite a difficult issue for food businesses because it forms from natural precursors, asparagine, that's just the standard amino acid, and sugars like glucose and fructose. And in wheat, it's asparagine that is the determinant of acrylamide formation. And we can, using genome editing, we've knocked asparagine concentration in the grain down by 90% in our small scale field trials. We've got two lines, one's down by 65 to 70%, one's down by 90%, which is fantastic. Bread made from that grain, acrylamide is below detection levels. You can start detecting it when it's toasted, but it's about 10% of the control cadenza. So that's fantastic. The technology works, and yield looks good again in our small scale trials. And again, we need to roll these out to bigger trials, look at things like yield on a bigger scale. But it's really encouraging the results we've got so far.
Great, and which is exactly what we're doing within the project. We're multiplying up at the moment. You mentioned there, of course, that we're in that particular line. We're looking at cadenza. We've also got a Claire as well, which is the tilling line, slightly older form.
So that's the old-fashioned mutagenesis.
That's the old-fashioned mutagenesis.
In that case, it was a chemical mutagen. So you just take 10,000 seeds or something, dip them in a mutagenic chemical, plant them out, and see what happens. And you will get tens of thousands, maybe more than that, of random mutations. But again, using the modern genomics that Cristóbal has referred to, we can identify plants that carry mutations in our target genes. Of course, they have a whole baggage of other mutations as well. So, but no regulations apply to them. That's one of the advantages. So we have that line as well. It's in the Claire background, which has about the same levels of asparagine as the line I said. It's about a 60 65 to 70% reduction in free asparagine concentration.
Mm.
So we'll be rolling that out within BOFIN this year, hopefully.
Yeah, and the difference with the Tilling Clare as opposed to the PBO cadenza is that Tilling Clare is already perceived as a conventional variety. We can grow it anyway, and that's what we're going to be doing within the trials is growing an area of Clare the Tilling Clare next to an area of wild type Clare. So we're comparing like with like, and that's quite an important aspect of this. So with all of the lines that we're bringing on within the project, we're working with Clare or cadenza or Fielder or Golden Promise, and those are lines that you wouldn't grow in most modern setups these days. But we are specific. They're the lines that the researchers have been working in. So they're diamonds in the rough, if you like. But it's specifically we want to see how they perform in the field, and then through
absolutely. And then of course you talked about conventional chemical radiation mutagenesis is now regarded as a conventional technique because it's been around since 50s and 60s. So I mean, it is quite ironic in a way, but I mean, GM's been around now since the 1980s, major crops in the 1990s. So at some point that'll become conventional, I guess.
Yeah. But
50 years from now, GM editing will be, oh, well, that's conventional,
Yeah.
It's this new thing we're worried about. But yes, in comparison, genome editing is a much more targeted technique. So if anything, it should be safer.
Yeah. Now, Nigel made the distinction there. Sorry.
Radiation mutants, and chemical mutants, they've been around in the food chain for a long time without an issue.
Dylan, Nigel made the reference right back at the start of what he was talking about between the research authorization and marketing authorization. Now, the lines that we're not going to be introducing into commercial fields any lines that haven't been cleared for marketing use. And so so they've actually completed their entire passage through the legislation, and they've got the stamp of approval from the Food Standards Agency and stamp of approval from the minister. So it's not until the minister signs it off that you can actually use these, and that could be quite a lengthy process. But can you just sort of explain, the difference? So there's the difference between the research elements and the marketing elements. What's the sort of key difference there?
For the research side of things, it can't be sold commercially. That's one of the big differences. It can only be done for research purposes. And the big difference is that no humans or animals can consume the product either. So you can just cultivate it. And this is going to be one of the key elements that the Food Standards Agency are looking for, because they want to be receiving nutritional content from plants grown under real world conditions. There's plants grown in very controlled conditions in glass houses do behave differently to plants grown in fields under normal standard practices. So a key stepping stone is going to be get this release for research purposes, growing the crops under real world conditions, and the closer to reality, the better. And then be able to obtain yield information, nutritional composition from these crops. And then that information will go to the Food Standards Agency, and then they'll be reviewing that, along with lots of other evidence. For example, the way typical processing might change nutritional content, and that has to be looked at in light of the changes that you've made to the plants as well. Just something you mentioned earlier, Tom, and somebody else in the chat as well, that this is just covering England.
Yeah, I was going to ask you about that. Yeah.
Wales and Scotland and Northern Ireland are different. So Wales and Scotland, these kind of agricultural policies are devolved. So it will be up to the respective Welsh or Scottish governments to decide on this. There is definitely conversations going on, but there's been no action so far in amending the legislation in Scotland and Wales. Northern Ireland is a very different situation. But this just covers cultivation. So once, say, a crop has been approved as a precision-bred organism, it will be able to be sold anywhere in England, Scotland, or Wales. So it's just covering the cultivation the legislation covers. But sale of that final produce can go anywhere within England, Wales, Scotland.
Great. No, thank you very much for that. And I'm keen to move on. And thank you very much for your contributions in the chat and in the Q&A, which I hope we'll get to. But I wanted to bring in Paul Temple, if you'd like to come in, Paul, and turn on your video, if you've got that.
Yeah.
Brilliant.
There we go.
Fantastic. Well, hopefully many of you on the call will know Paul, and he's been a strong advocate of novel genomic techniques, as they're called, for many years. So, Paul, would you like to just sort of introduce yourself and give a bit of background behind, your experiences with this sort of?
Okay, so I'm a mixed family tenant farmer, so we have beef animals and a variety of environmental grasses, and we farm a range of arable crops. And I suppose I was a classic farmer skeptic many years ago, but my driver has always been the application of science. I was fortunate enough to, when you begin your career in the late 70s and move into the 80s, you're used to applying science as it was presented to us. And so I got involved in field scale evaluation trials from what I classified as a neutral skeptical position. And then I learned a huge amount just literally watching what was happening in the fields with the guys who were running the trials, and appreciated breeding probably for the first time, because I saw both the conventional breeding and a novel type of breeding. And so it raised a huge amount of questions as to how we were going to make steps forward that we needed to make in facing the challenges. Now, what was really interesting to me alongside that was I learned a huge amount as to how this gets presented in the media. And I saw huge frustration in the fact that subjective, unfounded arguments were just laid into objective science. And that I found that really frustrating, which is why I sort of chose to become involved. And I suppose bringing the whole thing up to date, by being involved in the Global Farming Network, which covers 70 countries, I can see across the world how the science of plant breeding is being applied. And there is a huge range across the world. And what is really fascinating is it isn't just about large-scale farming. The aspect of precision breeding is of benefit to the smallest of breeders because it gives them the latest technology, regardless of the size of their farming. So that in a nutshell is why I have been engaged in the process. And I suppose I am constantly challenged with not what we're doing actually now, but where we're going to be in the future and the problems that I and the next generation or next two generations following me will face. And I suppose last year was a particular wake-up call to me in the sense that we had the lowest wheat yields since 1983. And if I hadn't been sitting on the combine, I really wouldn't have fully appreciated it. And what it shows to me is that we aren't seeing in the UK or Europe the trajectory of growing yields, and we are seeing more extreme weather events, and we know we're going to see future challenges in our ability to find the molecular chemical solutions. So plant breeding is absolutely vital in how we meet these challenges. And literally, we're talking about 3, 5, 10 years from now. So that's in a nutshell why I'm engaged in this, Tom.
Well, thank you very much for that, Paul. And you brought up sort of quite an important point there in terms of the restrictions of this technology, and just wanted to thank you very much to Charles Painter, who's a stalwart BOFIN member, one of our trialists, and has come up with a really good point that he's raised in the chat about, is this going to be narrowing diversity, and he talks about we've seen massive problems with biodiversity and many other issues that have been adversely affecting the overall environment, which appear to be feeding through to human health. So in short, will the use of this technology in this way, which is a continuation of the conventional thinking behind current breeding efforts, really benefit food nutritional quality and improve the worrying decline in human health? And so what's your view on this, first of all, Paul?
Well, this is, in many ways, this is the classic way it gets expressed. this is more likely to help the case than ever hinder it. The pressure that we have, and the UK highlights it, we put 780,000 more people on this small island. And we are seeing growing pressure across the world, and we are seeing growing pressure in the growing climates that a lot of the key producers are facing. And what this allows us is, and it's not a silver bullet, as Cristóbal pointed out, this allows the seed breeders a precise tool that can hopefully take steps forward to the variety of challenges that we face. So it depends on each issue you're actually facing. But in terms of this, is all net benefit. If you want to really address biodiversity decline, then you're going to have to look at wholesale changing practice. But you've got to remember, you're going to do this against a growing demand for food, and a growing demand from what we produce from the land. And the classic dilemma is, are we land sharing or land sparing? And this technology actually allows a little bit more amenity of the land sparing rather than trying to do it in the same place.
Yeah, no, I don't know whether any of our scientists want to come in. I noticed that you've answered it in the chat, Cristóbal. I don't know if you've anything else to add to what you've put there.
No, I mean, I think the point that he makes is completely valid, and I think the motivations that we have is that for the first time we can think perhaps beyond just yield, of taking Paul's point, but it's about yield and nutritional yield, and about making sure that we get yield in the right way with less chemical inputs, with preserving soils. But for those, we're going to need genetic tools to do it. I mean, we have innovated for the last 10,000 years. That's what we've done as a species. We've innovated, we've selected, we found plants that are able to. So we need to make sure we keep using that innovation to address these challenges. It's not the technology, but it's how we use the technology. And I think that's the key concept that we need to think about. So we want to be sure that farmers are in this conversation to tell us, this is how we want to use the technology to benefit biodiversity, to benefit deeper roots, to benefit soil scavenging, communication with mycorrhizae. And we're doing those things. And for the first time, we have a way to actually get that out. That, again, is not trying to vilify the breeding companies. They need to make a profit, but that profit usually comes from yield, because that's the only way that farmers get paid at the moment. So if we can actually shorten that and be able to go for traits that perhaps are not the conventional traits, we can then make some of these benefits, because we can find varieties that perhaps are better adapted for different cropping systems, or that can communicate with mycorrhizae even better. And those are things that are happening at the moment, and that's why we need this dialogue.
Great. Now, thank you very much for your contributions into the chat and the Q&A. And I just want to take a question from Charles Goldingham in the Q&A here. So thank you very much for joining us, Charles. And it's raised a very important point. And I was wondering, I was going to come to you first with this one, Paul. So clearly gene editing is very exciting and holds a great future for plant breeding. It's a massive advantage in that plants naturally breeds true to type, and the length of the plant breeding process is reduced. There's a 50-50 split, though, approximately, between certified seed and farm-saved seed. We need to ensure that the legislation protects farmers who wish to use their own seed of these gene-edited plants in combinable crops. Not only is this important financially, but is really important for food security, since the seed trade cannot cope without our increasingly variable weather and the changes that farmers are sometimes forced to make with their cropping. Now, this is quite an important concern for farmers, for breeders, and for really everyone involved in this technology. So, I mean, what are your thoughts on this, Paul?
Well, I've been involved in the seed royalties issues for many years. I was involved in the National Farmers Union. I was also involved in Copa-Cogeca in Brussels. And there is a lack of reality, in the sense of, if you don't put the investment in to seed breeding companies, you will not get the improvements. And the stark reality is, if you look what happened in North and South America, where they've accepted technology, they've seen the benefits, they appreciate the fact they're going to be paying higher levels of royalty, but their productivity has doubled in a very short space of time. And we do have to have a grown-up conversation as to how you are going to fund breeding techniques in the future. And it always used to make me smile, the fact that farmers thought when they bought conventional varieties once, they felt that that was it. They'd bought the effectively the genetic benefits, so they shouldn't have to pay for it anymore. And in the UK, we have always been particularly good, along with the French, of ensuring that royalties were coming back from farm safe seed to go to the breeding companies to continue that investment. And I think it is an area that is worth having a good conversation about. What I think is really important is farmers will never lose choice in this. The one thing I learned from the field scale evaluation trials, and I'm a seed grower myself, is you don't actually have to adopt this technology if you don't want to. There are conventional varieties out there. You can follow that path. This is not going to affect anything you do on your own farm. But if you choose, as you do with hybrid barleys and other hybrid oilseed rapes already, you will grow according to make the most out of that particular trait or variety, and understand there is a royalty element into it that has to be respected. And I think that is really important, and it actually gives confidence to those further along the food chain that we are managing this in a professional manner.
Yeah, I mean, that's really important. I mean, I think, you know, I mean, as a farmer myself, I've got absolutely no bone with paying a breeder to improve a variety. And if that means paying a higher premium, if I believe I'm going to get a return from that, then I'll make the investment. And that's what this platform is all about. Let's put those traits to the test to see whether we can actually get a return from it. But what I resent paying is a premium built on the fact that there are regulatory barriers that the breeders have to overcome. And I want to turn to you, Nigel, on that topic. Do you think that you've obviously been experienced in this legislation for a long time. Do you think that the legislation that we have in front of us is going to be truly enabling?
We have to see how it works, you know. In principle, if you look at the EU GM regulations, there's nothing really wrong with them. It's just that it doesn't work. And it's down to the committees that are meant to, you know, to put that process into effect. It just doesn't work. So on the face of it, it should work. But we have to see it working. And I do hope that within PROBITY, we can go through this process, show people how the pathway works. And I would just say, and I mean, I've been saying it to DEFRA, I say it to the FSA every time I meet them, if it's at all obstructive, then it just won't happen. Plant breeders just won't engage with it. So it's really important, not just for the regulations look okay, but, you know, it's possible to navigate through them in a reasonably straightforward manner and with scientific-based decisions.
Yeah, I mean, it's important to say that what we're looking at within the project and the varieties that we're bringing on, they are pre-commercial lines, and so we're not actually looking necessarily at the you know, how they're going to be marketed and what price they're going to come at. But we do want to have that conversation. That is really, really.
And we can go through the process even if we don't intend to market them, and that was done, for example, in the US with the first, I believe the first CRISPR variety was actually a mushroom with bruising control. And I don't think that's ever been on the market, but they just went through the process to show that it would work. And we could do the same within PROBITY, I hope.
We're coming close to the end of the webinar, but I just wanted to touch on, thank you very much to Helen Huyton from Hutchinson's, who has very kindly put in a link there about communicating with mycorrhizae, and so really interesting, worth picking up on that if you can catch but she raises this thing of traits, desirable traits, you know, so what are our priorities? I do actually have some, if you'll give me a second, I'm going to try and share my screen. We've actually done some work on this. We did a survey of our members looking at what traits would you see as the most desirable. And you can see what they're in order here. We asked people to rank them in order. And nutrient use efficiency, I mean, I think that's a bit of a no-brainer. It was interesting, actually, that people went for nutrient use efficiency rather than yield, out-and-out yield, which I think is quite a mature way to look at it. Pest and disease tolerance came next. And then there it is, the rooting ability, soil improvement, drought, salinity tolerance aspects coming in there. And then towards the bottom, human nutritional needs and food safety. So this is what farmers viewed as priorities. Now, I would suggest that the market is going to, if someone brings out a trait with high nutrient use efficiency, the market will respond and take that forward, and it won't be a problem. I think the ones where the industry might have a problem bringing forward is where the benefits for society, the benefits for farmers are less clear, which is the likes of the food safety trait, this low acrylamide, for example. And I think that's going to need some government support to take it on. But I don't know whether Nigel, have you got a view at all on this element of what the priorities are for traits?
Well, we know the priorities will be for farmers: is yield, disease control, increasingly, as we saw, nutrient use efficiency, because fertilizer costs are rising. Those are always going to be the traits. But I think, the acrylamide issue is one of regulatory compliance. That's always a big issue. It's further down the food chain maybe at the moment, but always something you should keep an eye on.
Great.
It's not just food safety, that's the point. It's regulatory compliance as well. I think that is really important.
Yeah. Now, I'm conscious that we've just about done all we've got time for. I'm sorry if we haven't come to some of the questions in the chat, but as I say, please do take them to the sequence circle. And I'm just going to share my screen again. Got a couple of slides to finish off with. So please do go to the sequence circle and bring all your questions and your comments and so on to the sequence circle. Just wanted to highlight a couple of things that we've got coming up. We've got a special webinar coming up in conversation with former DEFRA Secretary of State, George Eustice. He was one of the ministers behind the Precision Breeding Act and has a fantastic insight on the legislation. Now, as I mentioned earlier, there's also cereals and groundswell event. We have a seminar on the KWS seed to shelf stand on both days of cereals. We're also hoping for a seminar slot at groundswell, so do keep a lookout for that. And then planting of novel crops will get underway this autumn, as you've heard. So do find out more and decide if you'd like to be one of the first farmers across Europe to grow them. But whatever you do, please take the PROBITY pledge and bring your thoughts on the technology to the sequence circle. So do follow the link that's coming up. Oh, where is it? There we go. If you follow the link, you can sign up to the sequence circle. So it just remains for me to say thank you very much to our panelists, to Cristóbal, Nigel, and Dylan and Paul. Thank you for joining us. Thank you all of you for joining us. Please do look out for more details, sign up and stay in touch. And I hope you have a good rest of your day. So goodbye.